only if you use your formula to find your confidence interval, but you do have to know how to use the formula to find the margin of error. You do have to know how to find the ZC at least once. As long as you understand how to do it, you can use your calculator to find your confidence interval. I don't have a problem with that. So we're good with this? You tell me where the problems are. You had to find your margin of error. You have to find your ZC. Do not put in 0.95.
Not put in 0.95.
Yes.
Like I had a problem at first, and then like later on in the homework I started doing. But like the formula, it had like 2 equal signs.
Which formula?
The margin of error.
Oh, can you tell
It's
me
like
where?
It's like E equals the ZC population.
Right.
Standard deviation equals ZC.
Right, because they did ZC population, they do this. But then this guy, that's where this piece comes from, because we're using a sample. So it's technically, they kept this, and they redid this, like your central limit theorem did with the sample in it.
So you multiply the...
All you need to do is this, because you're going to get a sample.
So you don't really have to do that now.
No, because you really can't yet. You don't have you have a sample to use, so you got to use the n.
Oh, okay.
You got to put your population over your sample. So that's the only one you have to use. Remember how to find your ZC. You have a chart, but you have to know how to find it. Inverse norm, 1 minus 0.95, parentheses, divide by 2. At this point in your life, you shouldn't be having a parentheses problem.
And then you get...
It's more so
Yeah.
round up to 1.9.
1.9. Go to usually whatever the mean is. Since there's no mean, well, you can usually go. Technically, you should go 3 decimal places when there's nothing else, but 2 is probably fine. When we have a confidence interval, we're going to go the same as the mean, unless we do see one where it's very, very close, and I'll show you what to do with that. Erin, can you take off your hat, please? Okay. These, you just had to go by the rule. As you need to be more confident, as your confidence level increases, so like from a 90 to a 95, my confidence interval widens. And you need to use the word widens. So if I look for the largest confidence interval, confidence level, I'm going to have to find the widest interval. So the widest interval is this guy.
Do you mind putting number in the calculator? Because I did, but I...
You really can't put this in your calculator.
You have to know it.
You can't put it in your calculator because they gave you a mean, but you have no standard deviation to put in. You have no n to put in. So you can't. This exercise right here is just geared to say, as the confidence level rises, increases, and write this on your paper. Increases. The confidence interval gets wider. You need more wiggle room to be sure that you got everything correct. And that makes sense, right? As you need to be more confident, give me a little bit more wiggle room. Like, okay, say you need an 85 on this test. I got to be really sure I get an 85 on this test. So give me a little bit more wiggle room on this test. Maybe go from 83 to 86. I got to get right in between there. Give me a little bit more. If I need to be less confident, yeah, I can narrow it down a little bit. But if I need to be really confident, give me a little bit more room to play with. That's what it says.
So you can't put in...
You can't put this in your calculator. You have no standard deviation. You have no n.
What about the inverse norm?
The inverse norm isn't going to buy you anything.
I got lucky with that.
Yeah.
I did like the inverse norm, and then I added the number to 7.2, and I got all the...
Yeah, that's what I did. And I got it all.
You.
So I did like, for example, like the 1 minus 0.88 divided by 2, and then I got the 1.55. And then from 57.2, I added 1.55 and took away 1.55, and that's how I got my answer C.
That's what I did.
Oh, you went backwards to find your margin of error, basically.
Yeah.
Yeah, that's really long. Just go by this. Go by the confidence level. As your confidence level increases, your interval gets wider. Make sure you use wider. Much easier. And make it make sense. And don't say gets larger. Listen carefully. Don't say larger. Larger means there's more numbers. There's an infinite amount of numbers between any two positions. Any two positions. So you can't say gets larger. You have to say gets wider. Take the smallest one. Easiest way to start with your smallest and your largest. Which one has the narrowest bracket? C. Okay? Now, out of this one and this one, let's go for the larger of what's left. We used C and we used A. We're left with these two. Nicely lined up. Which one is wider? B or C? Or D? B. And then this guy, D. Okay? So use that concept. And that will help. And you need to know that as your confidence level increases, your interval gets wider. Now, margin of error, you can use, how many of you are using this step in the calculator? The test. This is a great one for confidence level. Everybody understand how to use the test?
Yeah.
Okay, let's run this one through. Stat, test, and it's right here. You're looking for an interval. Don't do a test. You want an interval. You're using z-scores. So you're right here. Go to stats. Data is when you enter your own L1. Here's your standard deviation. Here's your, God bless you, your mean. Here's your N. Confidence level. By you putting in your confidence level, you don't have to know the ZC. It will find it for you. It really is irrelevant to you. There's your interval. Now, here's your mean. It's sitting right here. Take this number and subtract your mean. This is your margin of error. There's your margin of error. So if I need to find my margin of error and I don't need to use my formula, I can just use my interval, subtract it out. They give you these numbers. Just subtract out. You could do this minus this one, but then you have to write them both down. So just take this one and just subtract them and get your margin of error. Remember, your margin of error is positive. In the long run, when you do x bar plus or minus, even if you put it as a negative, it'll still work itself out on the plus or minus, but keep your margin of error to be positive. It's technically a distance from the average, from the middle, from the mean. Okay, and I don't care if you use the calculator. I like the calculator for these steps. It makes a lot more sense. It's quicker. Once you know how to do it, why do it 100 times? That one, the same thing. Use your calculator, round to whatever your mean is, because you want it centered around your mean anyway. Now, number 25 was a nice one. You had to find the mean, and you had to find the margin of error. Use your number line. Write this out on your number line. Doesn't your mean fall in the middle? Isn't it the average of those two numbers? There's a number of ways you could do this. Easiest way, it falls in the middle. When something falls in the middle, you take the average of these two numbers. And there's your middle number. Your margin of error is the distance from your mean to the end of your interval. Then just subtract those and you find your margin of error. Okay? You can also take the difference between here, cut it in half. That's your margin of error. If you subtracted 14.8 minus 12.0, if you see it this way, cut it in half, there's your margin of error. Then add your margin of error to one of the to this endpoint and find your mean. I like the average one better. Whichever way you like to do is fine with me. But it's the guy in the middle you're looking for. Okay. Sometimes I think what happens, statistics makes a lot of sense, but you're so used to plugging into a formula, getting an answer, that you forget to step back and see how it makes sense. Are we okay with these? Oh, sample size. These are your sample size. I'll give you the formula. I'll give you the formula for that. It's a transformation of your margin of error formula. We did this yesterday. If you need to find how many you should put in your sample, they have to give you the margin of error. Remember in the word problem it said within, plus or minus. That's your margin of error. So you're going to plug this into your formula. You're going to round up. Because if I round it down, I never technically hit 125.1, which was my minimum that they wanted. But because I'm counting a sample, I need to count whole numbers. I can't have a partial.
How do you get 125?
Plug this in, find your ZC, which is in here, times it by this, multiply. If you can actually do the whole thing in your calculator just like this. Just run it like that. You don't even need an extra set of parentheses. Just make sure the whole thing gets squared.
Yeah, I forgot this one.
Square. Round it up. Same thing for the other one. Okay? Find your ZC. Make sure you do not, one of the biggest pitfalls, guys, is using your confidence level for your ZC. You want the Z-score associated with that confidence level. That's what the ZC means. Z-score associated with that confidence level. What throws kids off is the confidence level is a decimal. So is your Z-scores. But remember, you want the Z-score associated with that. Good? Okay. 33. This is the same thing, they just put words in here. A government agency gave you the confidence interval when estimating the mean commute time for the population of workers in a city. So, do the same thing we did before. Put it on the number line. Find the guy in the middle, that's your mean. Subtract the endpoint from the middle, there's your margin of error. Whether you subtract the 2, divide it in half, find the margin of error, and then find the mean, either way, it's fine with me. But I think if you put this on a number line and take a look at it first, it kind of does make sense. The mean is the average, the guy in the middle. All right, now we get into the good ones. In a randomly selected sample of 36 seawater samples, the mean sodium chloride concentration was 23 cubic centimeters per cubic meter, and the population standard deviation is 6.7. Pull this information out. As soon as you read this, pull this out. The mean in this sample, I have a sample size, I have a sample mean, and I have a population standard deviation. Remember in this section, we have to know our population standard deviation. Okay, we're going to construct a 90 and a 95% confidence interval. We want to see what happens to the interval as the level of confidence increases. What should happen to your interval? Wider. Good. So let's see if that happens. Your calculator is great for this. Because you put this information in, you look at this, you just change your confidence interval, you look at this. So you can do this in a flash in your calculator. Pull up your calc, let's put it in. For your non-believers. Pull up your calc for me. Go to stat, go to test, Z interval. Let's put your information in. But this part's not going to change. 6.7, your mean is 23, your N is 36, and at first let's do a 0.90. Here's your confidence interval. All this gets me right down to here. God bless you. There it is. Do we need all those decimal places? No. We're going to go to the same as our mean, which is 1. You could go 1 decimal place. I really don't like to do no decimal places, but you can if you wanted to. Then all you need to do is change this. Everything stays the same except this last guy, 0.95. Then write down this confidence interval. See it? That's it. That's the whole problem. All I wanted to know was your confidence intervals. Now,
So what did you do right there with the arrows that are pointing back and forth on each other?
well, I did this. If you rounded your margin of error to 2, these were exactly the same. Here, okay, this is a perfect problem. If the mean was rounded to a whole number. If you took your margin of error and you rounded it to 2, they look like they're identical, don't they? However, if I round it to 1.8, can you see a slight difference in it?
Yeah.
And if I use the calculator, can you see even a more distinct difference? So here's my point. If it rounds, if it comes out to be the same, we know they shouldn't be the same, right? If you increase your confidence level, your interval should increase.
So we don't even need to do that step, right? Because we have it in our calculators.
You don't need to do any of this. You just put this information in and you go right to here. Yes. Now, look at how much more exact this one is. Can you see the difference in your calculator? Your calculator is the most exact. Now, when you want to see what happens to it, lay it on the number line. 21, say go 2 decimals. To 24, to 24, 83884. Now, 20.8, is it going to fall to the left of 21 or to the right of 21? To the left. Nothing is to scale, you just need to get a placement. And 25 falls to this side. Can you see now that it got wider? Sometimes looking at the numbers down here, they look so close, they're kind of similar. I don't know. If you put it on a number line, you can actually see it widen. And remember, your interval widens or narrows. It doesn't get larger or smaller. This one was a good example of if we round too small, we really don't see that difference, and there should be a difference. So step back and do a decimal in there. And better yet, look how much nicer it is on your calc. Has anybody at least tried the calculator? Hey, I know I have a formula. Not really? You're not comfortable?
No, not really.
Yeah, this is so much nicer, isn't it? So much easier. Especially when you're changing just one thing. If you're changing your sample size or you're changing your confidence level, you just keep go in, change it, and then you move on. You don't have to redo everything. Okay? You work for a consumer advocacy. You want to estimate the population mean of replacing a car's transmission as part of your study. Here's the things you pull out. You randomly select 50. You have your mean for your sample. Here they are. You have your population standard deviation. And you want to construct a 95% confidence interval for the mean, the population mean repair cost. Now, when you interpret this, guys, this is so important. Here's your interpretation. You have to use what you said you were going to do. You want to be 95% confident, because this is what we did, a confidence interval, that the population mean repair costs fall between this number and this number. That's why you do this whole thing. You want to be confident that the population, not your sample, you know your sample is in the middle of it because you put it there. You're doing an inference about your population from your sample. That's why we do all of this. We also, did we go over sampling error at all? Okay, remind me when we get through this to talk about sampling error. I thought I gave it to you in your homework. I might not have. Okay, are we good with this? Everybody understands how to interpret this?
I get that.
So you're basically repeating the statement.
So wait, continue on.
It says construct 95% confident interval. So now, we are 95% confident that our population mean will fall within our interval that we just found.
Do I have to leave it at 117.8 or could I round it up to 118?
In this case, you see how their money has 2 decimal places to it? Even though it's 00, you could go 2 decimal places. You could do 2, like the money. Money has 2 decimal places. It probably just worked out because it's divisible by 50. It just
Wait,
worked out to point
You
50.
don't turn the 425 to 425.
No, that's $425. It'd be a little lot if that was your standard, if your standard deviation was that. Okay, in a random sample of 60 refrigerators, you got your mean cross and you got your population standard deviation. Remember, your population standard deviation, because this is a sample, your population comes from a previous study. In the past, when they did this, they found this was their standard deviation. They didn't find it from their sample. So you do all this, and how would I interpret this? Anybody want to give this a shot? Why did I do all this? To find my range so that I am 99%. What? What will fall?
The cost of repair?
Good. The population mean repair cost. I'm confident that my population, remember, it really looks like this. This is my population mean repair cost. I know my sample falls there. I know my sample is there. I found it. I put it there. That's my inference about my population. So I'm going to be 99% confident that if I surveyed, God bless you, every repair cost for this population, that it would fall between there. I'm going to be really confident that that's going to happen. If I want to be less confident, I don't need as much wiggle room. My margin of error will get a little smaller, and my interval will get a little narrower. Okay, this was a good one, because you can do this right in your calculator. If you put this in your L1, you have 2 choices. You can do your one bare stat, you can find your mean, your standard deviation we don't need because we're going to use our population standard deviation. You can find your mean, you know there's 20, you can just go ahead and do what you need to do. Or, you can put it in your L1, and when you go to your calculator, you see where it says data? You go to your data, and it pulls up your data from your L1, and it puts it in there. You still have to fill in your population standard deviation, and you have to fill in your confidence interval. But it knows what the mean is, because it's in your table, and it knows what the n is, because it can see it in your table. So you have 2 ways you can do it. You can let the calculator do that with the stats part, or you can do it here. Now, normally you need your mean anyway, but as soon as you do this, and I don't have this data in there, but I don't even know if I have any data in there. But as soon as I have no data in there. But as soon as you do this, it comes back and it says my interval and my x value. So I don't have to stop and take it. It will do it again and show it to me. So this is a nice little feature to use on the stats part. Again, if you did this in your calc, it's so much nicer. You're just looking to see what interval is wider. And we know as the level increases, the confidence interval gets wider. I gave you enough of these that you should feel fairly confident about this. Determine the minimum sample size. As soon as this asks you for sample size, guys, this is where you know sample size is my n. I have to find the n. That's the formula, n equals. No calculator step for this. You have to use the formula. Don't pack up. We're not done. All right, don't pack up. Remember to round up. And I'll give you the formula for those. Identify your margin of error. That's the within part. The within one, it's obviously within one, you don't have to divide by anything. You don't have to do the divide. Just do the multiply and square them both. So square the product. Okay, this was a nice one too because we repeated this. This is a good one to notice. We did a 90% confidence interval. Then we did a 99. If you're going to be more confident, you need to have more in your sample to make sure you have a good sample. So to be more confident, my sample size is going to increase. And the reason that happens is because of your ZC. It's a larger number. So doesn't that make it a larger product? Right? It makes sense. Part of the problem is you guys have to make sense out of this. Okay. And as you need to be more confident, you need a larger sample. All right, there was one part that I think we missed, and I thought I had it on here. I might have quickly gone over it and not seen it. Oh, here it is. I didn't give you 9 or 11. So if you just take a look at number 9, because you're responsible to know this. You kind of breezed over this. And I forgot to give you number 9. It says use the value to find your sampling error. Your sampling error is the difference between the sample mean and the population mean. Subtract your sample mean minus your population mean. That's all it is to find your sampling error. Because with our samples, sometimes we're not exactly on the mark with population. So we get a little bit of a sampling error. That's the greatest difference between the two of them. Now, if you subtract the sample minus the population mean, if the sample was short, you get a negative. If the sample is bigger, you get a positive. So remember to be able to do that too. That's the sampling mean error.
But it'll give it to you, right?
They have to
It'll
give you
give
both
you the
parts.
X and the U.
Yeah. It's just the difference between them, and it kind of makes sense. It's where your sample is a little bit off. The error of your
So it's
sample
like
mean.
a quiz test or just a
Quiz tomorrow.
or like is it quiz like a quiz test grade or just like